Hey everyone, welcome to the first video of Intuitive Stats. So I just want to give a brief overview of what you can expect out of these videos and what are my goals out of them. So as the name suggests, Intuitive Stats, essentially my goal with these videos is to leverage your existing intuition of statistics, which does exist by the way, whether you know it or not, and develop that, make it more precise, formalize it, and give you the abilities to essentially develop a strong mental map of different concepts and stats. And so what do I mean by existing intuition in statistics? Well, I think stats is a field, unlike a lot of other fields, that is very, very heavily intertwined with our day-to-day lives. And so just by living our day-to-day lives, we're getting exposure into different statistical concepts. And I think if leveraged in the right way, we can essentially make the learning process of statistics much more effective, much more enjoyable. And so that is my goal with these sets of videos. So if that's interesting to you, please keep listening. So I want to start by defining what is probability and what is statistics. I think this is, these two fields are commonly mistaken and confused. And so I just wanted to start off by, giving a definition. So probability is something that you've come across probably hundreds of times in your life. Whether you've actually taken a probability theory class or not. And so formally what it is a field that focuses on their events and their likelihoods of occurring. And so overall it's a very deductive field. So essentially probability stems from three axioms and three axioms only, the entire field. And essentially from those three axioms you can come up with several hundreds of thousands of deductions and the probabilities of several outcomes occurring. And so let's start with a few examples that you might be familiar with. So probability that you toss heads on a fair coin. Right, so even if you've never taken a probability class in your life, I think you can have a good intuition of what the answer of this is, right? So what is a coin? It's essentially like a piece of metal and it has two faces, right? It has heads and it has tails. So what do you think the probability you toss a heads is? I would wager that most of you said a half or thought a half in your head. And now let's try to think about why did you think a half, right? Why was that your intuition? Well, there are two possibilities, right? Heads and tails. And a coin is, roughly equally weighted, even though it's slightly off. But we can say for our purposes that, it's roughly equally split between heads and tails. And so you would expect, around 50% of the time you get heads, 50% of the time you get tails. Makes sense, right? And so what essentially are we saying? We're saying that basically the probability that we toss heads is 1 over the number of outcomes, which I'm going to denote as n. And so let's go to the second example. So the second example is what is our probability you roll a 4 on a fair 6-sided die? Do you think the same framework of 1 over n applies? Well, I think it does, right? So again, what is your intuition, right? So you have a fair 6-sided die. Fair 6-sided die means what? It means that there's 6 possible outcomes, 1, 2, 3, 4, 5, 6, and they have an equal likelihood of happening, right? That's what fair means, is that the die, again, is roughly equally weighted. And so when you roll it, you will expect to get a 1 about as often as you get a 2, about as often as you get a 3, and so on and so forth until 6. And so here you would say that okay, so the probability that I roll a 4 is 1 over 6. So this concept actually for these first two examples is related to what is known as the naive definition of probability. What the naive definition is basically essentially you're counting the number of outcomes that you define to be a success. So a success in the first example is a heads. A success in the second example is a 4. I could also define it to be a 4 or a 5, right? So then we have 2 outcomes. But essentially, again, the naive definition of probability is just the number of outcomes that you define to be a success over the total number of outcomes. And so if I asked you, what's the probability you roll a 4 or a 5 on a fair 6-sided die, it would be the number of outcomes you define to be a success, which is 2, right? 4 and 5. So 2 over what are the total number of outcomes? 6, right? So the probability you roll a 4 over 5 is what? 2 over 6, or 1/3. But obviously this doesn't hold. In a lot of other cases, essentially there are assumptions that are embedded into this naive definition of probability, hence why it's called the naive definition. Okay, so now let's go into this third example. So what is the probability that a person develops lung cancer? So this is much harder than the first two examples, right? The first two, you probably had a good intuition of like, okay, the answer to 1 is 1/2, the answer to 2 is 1/6. But what about the third one? Well, the third one is probably, I would argue, the most relevant. It's something that biostatisticians and people actually study, right? There are journal articles about this. Things that, might affect... Well, okay, let me start here for a second. So the probability that a person develops lung cancer is probably different depending on the lifestyle of the person, right? So I'll give you a concrete example. So let's say that we have a smoker, someone that smokes every day, and we have someone that lives a very healthy lifestyle. What would you think in relation of probabilities of the likelihood that the healthy person versus a smoker would develop lung cancer? I think intuitively you would think like, okay, I would expect the person that smokes more to develop lung cancer, and the person that is healthy to have a lower chance of developing lung cancer. And I think that intuition is generally correct. And not only does it hold for, that sort of lifestyle difference, it probably also holds for other factors, right? Your age, where you grew up, maybe some genetic factors that you have. And so this is actually something that can be estimated using statistics. So now let's actually jump into statistics. What is it? So statistics, in a way, is the inverse of probability. So it's a field that focuses on the analysis and interpretation of data. So you're basically starting from observed data and you're making deductions or conclusions about your starting hypotheses. And so I would describe it as inductive versus probability was deductive. So you're starting with data and you're making statements about hypotheses, their uncertainties, etc. So I'll give you an example here is like, suppose you start with the hypothesis that a coin is fair. And then suppose you flip the coin 10 times and you see 10 heads in a row. So what can you say about that original hypothesis? Even if you've never taken a stats class before or probability class, I would wager that most of you would think like, it's pretty unlikely that like you get 10 heads in a row if, you have a fair coin, right? Like you would sort of expect like, roughly 50% of the time you get heads, 50% of the time you get tails. So if you toss it 10 times, like, I kind of expect to have, 5 heads, 5 tails. And I think like that intuition is roughly correct. And I think like with this, obviously this is very nebulous, what I just said of like that intuition is roughly correct. But I think that's a good starting point when you're sort of thinking about like, how do I actually evaluate this? Like, what is the chance of me seeing this, assuming that this hypothesis is true? And does that seem like a reasonable probability? Like, if you only get 10 heads in a row and the coin is fair like 0.01% of the time, then it's probably unlikely that like the coin is actually fair, right? So your starting hypothesis is probably wrong. And so that's basically the field of statistics. Or I wouldn't abstract it that far. I'd say like that's an example of what you would look at in statistics. And this third example is also something that you would study with statistics using statistical methods, even though in and of itself it's trying to estimate a probability. Okay, so why even study statistics in the first place? So I think there are probably two major reasons that I think should incentivize you. Firstly, I think statistics, again, is intertwined in your daily lives. You see it everywhere. You go on social media and you see like, these statistics. You go on the Weather Channel and you see, there's a 70% chance of rain. read these news articles, like there's a 30% chance that this stock increases by 5%. There's a 7% chance it increases by 32%. You see all these numbers, right? And even in published journal articles, like you see statistics everywhere. And it's so prevalent and it's so misused on social media, of course, but even in these published journal articles, like you're seeing the misuse of statistical methodologies and people sort of just applying methods without actually fully analyzing and understanding what it means to be using those methods and what are the assumptions that are built in. And so I think understanding statistics, then sort of that implies that like you become a more educated consumer of knowledge, right? You're able to understand like, okay, this person's using X method. X method assumes X, Y, Z, and given the context, I don't really think that X, Y, Z hold, or maybe only Z holds. And I would want to ask questions about whether X and Y actually hold. And so to be able to make critiques and be an educated and critical consumer of knowledge, I think is very important. So you're not just swayed by, what is all these sensational numbers that people like to have as like clickbait or whatever you might have it. And secondly, I would say, if you are a parent or you are someone that is, attracted to dollar bills, statistics is a subject that's super high in demand. Machine learning is like sort of like the key word of like the last couple of years, I would say. And what exactly is machine learning? It's literally just the development of statistical algorithms. And so again, like the underpinnings of ML is just stats. And so having a good statistical foundation is what is going to get you to become that superb ML engineer or data scientist or AI specialist, right? And all of those areas are really booming. And I would say that like we've collectively hit a point where I think here forward, like it's going to only be used more and more by more and more companies, and more funding is going to be given to these areas in academia as well. And so I think we're going to see a lot of progress. And there's going to be jobs that are very high in demand, skill sets that are very high in demand. So again, from like a monetary perspective, I also think that this is a good investment of your time. So I just wanted to lastly reiterate the goal of these videos. So the focus is on leveraging intuition and frameworks. I think intuition is a super powerful learning tool. And I think it's especially powerful because statistics is so intertwined with our day-to-day lives. And so everyone has a baseline understanding of statistics, whether you know it or not. And so the goal will be to essentially formalize that, make it more precise, hone it, and build upon it. And in doing so, developing strong frameworks. And what I mean by frameworks are just ways of approaching problems, and to be able to, essentially look at a problem, abstract to the key ideas, and then apply frameworks to basically get an answer to your original question. And so my ultimate goal from these videos is to give you strong mental maps of different statistical concepts, and hopefully at the end you'll be able to apply those ideas to unseen contexts. So if that's something that you're interested in, please be on the lookout for further videos. But yeah, that's all for now.